everybody. Thank you so much for coming to the Business and Reporting Lightning session. So we've got 10 fantastic speakers here for you today. So I have no control over the slides, so once we push the button, we're all going to go. We're just going to do it. It's going to be fantastic. So just a recap on the format. We have 5 minutes per speaker and 20 seconds between each speaker as well. The slides will move automatically every 20 seconds, and if our speakers didn't have 15 slides, it'll just halt on the last slide until their 5 minutes is up. So it's like, this is a pretty kind of interesting format. I think it's going to be fantastic. So let's get this started.
Hi, my name is Francis. I probably have the longest name in this conference. So I would like to talk about R and Tableau integrations tonight from the perspective of mapping, all right? The main purpose of the talk is to highlight the basic steps to take if you actually want to have a quick, simple, yet interactive map. Because Tableau is actually straightforward and easy to use, what you need to do is to manipulate the data structures and pass the message data to Tableau. A little bit about myself. I'm working in Singapore for SingHealth, which is the public healthcare system in the eastern regions of the country. Now, I would like to emphasize that you don't need a lot of knowledge to get a map in Tableau, because, but it would be useful just to know a little bit about Tableau, dabble with R for some time, and basic secondary school geography, all right? So don't worry about that. Now, the first thing you need to do in Tableau is to connect your base map with your preferred map server by adding the URL of the server. I normally recommend OpenStreetMap, and you can visit their Wikipedia website to obtain the WMS, which is web map service for the URL. Now, once you have the base map, zoom in, zoom out, okay, scroll left, right, all right, but that's it. This is just a base map, right? So with no data on it. The next step is to go to R, get some latitude, longitude data, and plot the points on the map. So assumes that you have the latitude and longitude data, you can import it in R and perform projections. This is for my case because the data I normally receive is not in the standard WGS84 format, so I have to convert it. Of course, if your data in the standard WGS format, just go to this step, all right? So you drag the latitude and longitude, but of course you have to specify it, which is what is wedge, and then write them to column and row, and Tableau will automatically display the map with the points on it. The next map is actually slightly trickier, and you need to do a little bit about polygon and shapefile. I hope you know a little bit about that. Assumes that you know and you have the shapefile. Let's first read your data in R and project in the standard WGS84 format. Now, sometimes the polygon is formed by the sets of points and lines connecting the points in sequence. The R code here simply extract the coordinates and plotting order. The R code is kind of like badly written, but it's aimed to show you the step of how to do it. And now, after you export the data in Tableau, drag the coordinates to respective rows and columns, and then change the chart to polygon. Then specify the plotting order by dragging the fields to the path. By adding the region's colors, you can drag the dimensions of the regions like name, ID to color, and voila, you have this region map. Sometimes, well, you want to color code the classifications like populations, categories, sales ranking, election result by constituency. You can actually specify that by going to color, reduce the opacity to show the street and base map, edit the color by assigning the color palette to, of your choice, and you will have the map shown here, right? But sometimes you want to contrast the regions without showing the detailed street map. Just increase the opacity to 100 and then you will have the map in the next slide. Notice that all of these are actually done in Tableau. So to sum up, you can actually have a very simple and basic map by just export the data out from R and then map it in Tableau. But you can actually do a lot more with R, to be honest. And I know the talk is short, so I'm gonna say that if you have any questions, you can contact me via emails in my profile in the conference app. Thank you very much.
I'm going to wait for my slide, otherwise it'll definitely go wrong. Yeah. Can everyone hear? Is that okay? Cool. Good. I'll shout even louder. Okay, so my name's Rob Noble-Eddy, and I'm a data scientist at Capital One in the UK. I'm here to talk about our first R package released to the external world called Data Comparer. I'll talk about the package for most of the 5 minutes, but I'm going to start with a quick intro to Capital One for those who don't know. So you may be familiar with Capital One as a large bank in the US, where it offers a full suite of banking products from loans, credit cards, mortgages, everything you can think of. But Capital One also has a presence in Canada and in the UK, where it offers only credit cards. About 2 years ago now, Capital One declared it was going to be an open source first organization. And for us in the data science team, that meant moving from SAS to R, which I guess is why I'm here today. Since then, we've tried to be active in the community. So, for example, we host the local R meetup group, which happens every month or two. And hopefully this first package of many, I hope, is a sort of stepping on that journey. So one thing our team do a lot of is comparing data sets or data frames in R. An example of this is if we're deploying a model in production, you want to check that the inputs and outputs in production match those you had in development. And in SAS, there was a useful function called proc compare, which would do that for you, and we used it a lot. In R, we struggled to find a replacement, so we used or.equal, which on the screen here you can see two data frames with some differences highlighted in red, and the output of or.equal can be seen below. And whilst it does tell you everything you need to know about the differences if you work hard, it's not very easy to use. So what you can see now is the output of our new package, Data Comparer, which hopefully provides a much richer summary of the differences between two data frames. I should point out this is the HTML output, so normally this would be in one long list in a web browser, but hopefully on the left you can see that you get a summary of what's in your data frames, which rows and columns match between the two data frames. And on the right-hand side, you get a more detailed breakdown. So where columns have mismatching data, a summary of that data and some examples which can help you understand why your data might be different. Obviously, what you care about when you're comparing two data frames depends on what you're doing. So we try to provide as many options as possible to tailor the comparison to your need. So you could choose to compare your data just based on row order alone, or you could specify one or more ID columns to join your data sets together. We also have functions like rounding numerics, trimming white space from strings. Whatever you do, the output of the comparison is an S3 comparison object, which you can then interrogate in a number of ways. So probably the most useful is summary, which gives you a really verbose summary of the differences, pretty much anything you could think of that you might want to know as a difference between the two tables. And you can save that to Markdown or HTML. If you want a more concise output, then print just summarizes that in far fewer lines. And then if you want to drill into the differences of the data, you can actually extract the mismatching data into a list of two data frames using the generate mismatch data function. That's all I've got time for on the package itself. I just want to briefly cover how we built it, because I think it's a bit different to most packages. Rather than having one or two authors, we actually have around 18 authors in this package. And that's because we built the package in a 2-day hackathon involving the entire data science team. Now, it did take a bit of planning up front. We had to know the sort of structure and layout of the package before we started. But we managed to get through the bulk of the work in 2 days. And it's probably worth pointing out, we split into dedicated coding and unit testing teams. So we did unit testing almost as a separate activity. And you can see from the GitHub commit graph there that we had really parallel sort of branching strategy to begin with. I learned loads during this effort. I can't talk about much of it, but what I would say, and I'm probably preaching to the converted a little, is that the value of having unit testing was immense. We managed to get to almost 100% coverage, and that just gave me such confidence when I was making changes later on that I wasn't inadvertently changing something I wasn't intending to. I really hope to stand here today to tell you you could go and get this package on the CRAN, but I made a small error in my submission. So as soon as I get back to the UK tomorrow, I'm going to resubmit. For now, it's on GitHub, on the Capital One public GitHub. You can contribute. Any issues or pull requests are welcomed. That's all I've got time for, other than to say that if you're a collector of hexagonal stickers, of which I think there are a few people who are, then I have loads. So come and get some either now or tomorrow morning. Thanks a lot.
Yeah, it's easier. Okay, good afternoon, everyone. My presentation is about an R template package to automate analysis workflow and reporting. It's a type of R package. It's work from a colleague of mine, and it's an approach that we often use, and we would like to take this lightning talk to propose this approach to you. The goal is to automate parts of an analysis workflow to focus on only the analysis-specific part. Advantages are that you can deal with recurrent analysis. It's a standardized, reproducible analysis. You're less prone to errors, you save time, and you can focus on the important part, the experiment analysis-specific one. Our approach and a possible strategy is to make use of templates within an R package. So you have child documents, which contain in a way the redundant part of the analysis, and then a master document, which is a starting point with the experiment-specific parameters that calls the different child documents. Now, how does the structure look like? So you have a start, which then calls a main general child, which calls on its turn different sub-child documents. All the child documents in the blue box should be contained in the R template package. We work with the approach of a main general child because in this way you can easily add other modules without having to modify your start. The start as a master document contains the analysis-specific parameters like data, modeling parameters or other parameters, the output path analysis, so everything that is specific for your experiment that you're considering. Now the start will then call a main general child, and this main general child, it actually contains the main structure of the document and the calls towards the different child documents, the specific parts of the analysis. So like I mentioned, the way of working, it's easy to add another specific part of the analysis later on because you don't have to modify your start. You can easily update it without any issues. Then you have the specific child documents, so specific sub-analysis of interest, like for example in your discriminant analysis, a pairwise comparison, and so on. So it's code which is the same across your experiments. It's in a way redundant when you look at a specific experiment because the code stays the same. So an R package, but it's a specific one. It's an R template package. Within the inst folder, you have a templates folder, which contains child documents. You can also specify some layout specifications in a CSS file, and you might add a starting template. So with this one template package, you can create multiple reports, different reports. An advantage of an R package is that it's reproducible via versioning. It's easily to adjust code. You can correct bugs, extend analysis, create additional parameters, also for code transfer. And like I said, it's possible to create a start template, which facilitates a quick start for new users. So you can run different master reports via parameterized report calls. So you have your render statement, and within a params option, you specify your parameters. This also allows to create a Shiny application to run reports, which is user-friendly also for users who are not familiar with R and want to run a specific report. Tips and tricks with respect to coding: add messages throughout your document, give chunks an informative name, specify general knitter-panner options for your chunks, add session info at the end for reproducibility, and a small side note, make sure to use unique parameters throughout all your documents, the master and the child. Also some tips and tricks with respect to user-friendliness: facilitate to use only part of the available analysis. Like, do you want a box plot or not? Do you want a pairwise comparison plot or not? and make use of default values for the parameters if it's not specified whether there should be a histogram, for example, included by default. And it's always nice to add sentence which who developed it. So we created an R example template package, one package which results in multiple different reports. Here you see 4 examples, 4 different data sets, and for the different examples we also consider different parts of the analysis. So this is all coming from the same example R template package. So to summarize, create your own R template package. You can deal with recurrent analysis. It's a reproducible report in a standardized reporting format. You save time and you're less prone to errors. All the tools are actually already available, so you can really start and do it yourself right now. We created an example template package, which is available at the GitHub of our company. And if you have questions, you can contact Laura or myself during the conference, or contact us via email, and we also provided some useful links. Thank you very much.
Great job, great job. No, I'll take this one. Okay. Thank you. So hello. I thought I wouldn't have time to say hello. Yeah, I'm ready. So I'm Liz, and this is Graffiti. That's a Shiny app which aims at making it easier for people to produce nice plots based on the ggplot2 package. So you can use it online at the address written in the upper right corner, or you can get the code from my GitHub repo. Now, to use this tool, you'd first start, of course, with loading your own dataset, but you can also use a preloaded fake cat-related data, which is convenient for my purpose because it compresses a bunch of either categorical or quantitative variables as well as fancy cat names. So once you choose one of your variables as X variable, then you can create a univariate plot, and according to the type of variable at hand, you have different possibilities in types of representation, or geoms for ggplot2 users. So if you had both X and Y variables, for instance, and both quantitative, by default you would have a geom point, but you could also have geom text, lines, and so on. So you've got visual hints as to what you're able to do with the tool. Like if you had a categorical X and quantitative Y, then you'd have a box plot proposed to you by default, but you could have violin plots and so on. So you can actually add several of these geoms. Like for instance, I have added a geom text to a geom point in order to show my fancy cat names along with the relationship between their weight and hair color, for instance. So we can add up to 3 of them. I get to breathe here, okay. So for each of these geoms, you'd be able to parameterize a certain amount of things, like for instance, filling color, symbol or line size, line type, etc., according to the geom at hand. So here, for instance, I set filling color to yellow. But you also get to relate some of the graphical parameters to variables. That's called mapping variables to aesthetics in ggplot. So here, for instance, I related the cat's sex to color, to filling color. Et voilà. So that's actually the moment where I get to really breathe and just show off a little, because basically Graffiti produces ggplots, so they look nice and they're varied. Now, for each of these graphics, you have the possibility to set a certain amount of general parameters, like height and width, axis labels, axis transforms, the themes, the color scales, and so on. And you also get to use one very useful feature of ggplot, which is facets. That's to say that you can multiply facets of one graphic according to the levels of categorical variables. So here, for instance, I got facets according to sex horizontally and type of cat food. vertically. So of course you might want to export your graphics once you're all set, and you get to choose the format and size of it. But maybe you would rather have directly the command lines which generated the graphic in the first place. And you can actually do that with Graffiti. So even if you're really big on reproducible research, you can actually fiddle with the tool. And once you're ready, you copy and paste your command lines into your R Markdown document, for instance. So how can that be useful to you? Well, chances are it won't be useful if you're already a ggplot superstar. But it could still be useful if you're in the process of learning how to make your plots with ggplot, for instance, and you need some kind of interactive cheat sheet along the way. And it's also quite useful if you teach ggplot or R, for that matter, to people, either students or even colleagues, and you need to give them a quick feel of what ggplot can do for them. That's it. Thank you.
One, two, three. Oh. Okay, so I'm going to start in a second. I'll just say that I'm very excited and happy to be here and give this talk. So my name is Tal Galili. Today I'm going to talk with you about a package I co-authored called the Heatmaply R package, which is for creating interactive heat maps using R and Plotly. Now this package is thanks to many people. I want to specifically thank Joe Cheng for getting me interested in this topic to begin with when he invited me to co-author D3 heatmap. Also to Ellen O'Connell, I'm not sure how to say his name, Ellen who has helped with adding more features, Jonathan Seedy for adding a shiny version of this package, Carson Sivet for his amazing Plotly package, and also to my PhD thesis advisor, Yoav Benjamini. So why do you want heat maps? Well, sometimes you get a table and you want to turn all these lovely numbers into shades of colors. And then you maybe want to rotate the columns and the rows so that you would better see patterns that you're having in your data. So that's why you might do hierarchical clustering and attach those elements to the sides of the plot. And what Heatmaply does, the same as Heatmap2 in gplots and so many other packages and functions, is doing exactly the same, with one difference, and that is that you can then use the mouse to see the values when you hover over the cells, and you can zoom in into aspects of the cell. And if that was all, I would stop here. But a lot of thought was put into creating defaults into the package. So one of them is to use the Viridis color palette, which I'm sad to say I did not see enough during this conference this year. So the Viridis color palette is great for many reasons. It's pretty, it's colorful, it's perceptually uniform, and it's great for printing in black and white printers. It's mainly good for ascending color scales. For example, when you have counts of things, or when you have something starting from 0 and going up. And when you don't have something like that, you may want to use a different color scale. For example, a divergent color scale from the R-Color-Brewer package. So here we have a correlation matrix where you have 0 in the center and it goes from -1 to 1. And you want the colors to go to different directions from 0. And for that, a better color scale could be something from 0 white to blue or to red. Now, another thing that I encourage the use of is transformation before you create your heat maps. So for example, in the upper corner, you have an example of count data of some sort. And there, because it's very right-skewed data, if you use a square root, you get a better sense of the data because it diminishes the effect of extreme values, and you can better see the pattern. On the lower part, you see an example of visualizing a matrix with very different types of variables of columns. And there what I did is I used the ranking for each column, and that way I was more able to see, this is empty cars, I was more able to see that there are two different brands of cars. So another package that I'm leveraging is this dendextend R package, which I authored with many other people who helped me. And that package is what enabled me to take a dendrogram object, turn it into a ggplot, turn that into Plotly, and then connect that into a heat map so it would be interactive. And a lot of features are thanks to that package. For example, we get dendrograms with colors that could highlight the different clusters we have. So you can, for example, explicitly state it by using k underscore row equal 4 and get the 4 distinct clusters in your heat map, or use NA, in which case the number of clusters is chosen automatically by something I just forgot. Another package I work with is seriation, which rotate the dendrograms to reach optimal leaf order, which means that each pair of rows, the sum of their distances is minimized. So that is better default than any other package out there, sadly. And all of the features that I just described are available through a Shiny app called Shiny Heatmaply, written by Jonathan City, where you can go through each one of the things I just described. You can load a file, or you can run it as a widget, in which case you can plug it into an R object. You can choose your distance matrix, your H-cluster object type, like linkage function, number of clusters, and at the end of it you can download an HTML file with this interactive heat map. And in general, Heatmaply creates something that you can see in your RStudio viewer. You can embed it into a neatar object. You can save it as HTML. So thank you so much for entertaining this talk, and I hope you have questions and so on, which you can email me or ask me after the talk. Have a great rest of the conference. Thank you.
I'll just wait for that. All right. Hi, everyone. My name is Dean Atali. I am a Shiny consultant, and I'm going to talk about a tool called Plot Color Helper. This tool is available in a package called Color Picker, and it is on CRAN, so if you want, you can download it and try it out for yourself. Now, what this tool tries to solve is this problem that I've run into quite often, which is once I create a plot, I often want to add good colors to it, and usually I try to use our color brewer or one of the built-in palettes, but sometimes it's just not good enough. So I manually add colors, and often I have to tweak those colors a lot of times until they're right. So this process of finding the right colors for my plot can be very tedious. So with Plot Color Helper, it takes away that need for blindly choosing colors and replotting 100 times. So what you do is you highlight the code for your plot in RStudio, and then you go over to the add-ins menu and you select Plot Color Helper, and that will help you iterate through different sets of colors for your plot much quicker. So what you have on the left side is a big text box with the code for your plot. So this is just the code that you highlighted before. It's just copied over, and you can also edit it if you want. Then on the top, you have a list of colors, and you'll see that there's 5 colors right now. That's because the tool actually tries to guess how many colors your plot needs, and this plot does have 5 different levels, so it has 5 colors there. And on the right side, you'll have your plot. So this plot will get updated automatically whenever the code changes or whenever one of the colors change on the top. Now, the way that works is that those colors on the top, that list, it's actually always going to be assigned into a variable called cp_cols. So if you look in the text box, you'll see I make a reference there to cp_cols when I want to use the colors. So cp_cols will always be a vector containing the values of the colors that you see at the top. Now, if you look at the bottom, you'll see that there's 4 tabs in this add-in. So the first tab was the code itself that you saw before. The second tab that we're on now is the Any Color tab. So here you have a color selector where you can select any color. And so if you, for example, select pink in this color selector, then you'll see that in the plot itself, all the points that were blue before now became pink. And if you look at the top, the box that was blue before with the number 1 in it now became pink. So you'll also see there's a little black outline around the first box. That outline means that that's the currently selected color. So if you choose one of the other boxes, either with clicking on it or with keyboard shortcuts, then you can choose a different color to edit instead of that first color. You'll also see there's 2 buttons to the left of it. There's a plus button and a remove. So you can also add or remove buttons from that, colors from that list. And that can come in handy. For example, if you want to add a background color to your plot, like I've done here, I've added a third line to the code that adds a background color. And that background color refers to cp_cols bracket 6. So to do that, to make that work, I just had to add a 6th color to my list of colors on the top. Now, once you're done selecting colors and you're happy with them, there's two side effects that happen. First of all, that CP calls variable that holds the vector with the values of the colors you've chosen, it gets assigned to your global environment, which some people will think is a bit too intrusive. And also, you get a CP calls variable declaration in your source code. Now, there's another function in Color Picker that you might find useful. If any of you write Shiny apps and you ever need your user to select colors, then you can use the color input function. That's actually the original purpose of the Color Picker package. You might be able to use that, I saw. Then now for a little bit of history, I actually had a similar add-in last year called Color Picker, which what it lets you do is it lets you select a list of colors and then return that back to R. So it was the same thing, but without the plot component. Now, my girlfriend was working on her thesis at the time, and one day she came up to me and she was venting about how it's taking her so long to come up with colors for all her different plots. So I told her, oh, just use my awesome Color Picker tool. And she looked at it and she said, well, that's pretty much useless because I can't actually see the plots when I'm changing the colors. So I thought, that's actually a great idea. I should add a plot beside it so that you can see the colors while you change them. And so that's an example of why I think feedback, and especially criticism, is really important when you're building tools for other people. So if anyone has any suggestions or comments, feel free to let me know, either in private or in public. And there's a lot of people I want to say thank you to, but I don't think I have time, so I'll just say thank you, everybody.
Hi, everyone. My name's Ian Little, and I am pleased to speak to you about a package I've done called BS Plus, where we can use some Twitter Bootstrap to extend your Shiny app. I work for a company called Schneider Electric, and I am terribly pleased that they sent me to this conference. I work in the Analytics, Applications, and Programs team. So first of all, to say thanks to the organizing committee, the volunteers. It's been an amazing conference. Grace, thanks for chairing. Fellow speakers, thank you. Eric Bailey wrote the Shiny BS package. You may be familiar with this. My package was inspired by his. And thank you all for being here. So why yet another package to go with Shiny? Twitter Bootstrap, on which the Shiny UI is built, offers a lot of stuff that you can do simply in HTML without worrying about the server side of Shiny. Collapsible panels, accordion panels, tooltips, pop-ups, modal windows. And what I wanted to do was to get away from the server side of Shiny, do it purely in HTML, conform to the Twitter Bootstrap API, so that means I do less. The less I do, the better it is for everyone. And I also wanted to write a package that uses or will abuse pipes. So here's an example. I want a collapsible panel. So I create, using this function bscollapse, I give it a unique tag or unique ID called yeah, and then it's just a paragraph with yeah, yeah, yeah. Yeah, yeah, yeah. So to get it to do something, I create a button, just a standard, using HTML tools button. Give it a title, She Loves You. And then I attach that button to the tag yeah, and when I hit the button, She Loves You, yeah, yeah, yeah. And attaching, in fact, you can attach an ID to as many buttons or links as you like. So I could create another button, call it She Liebt dich, attach it as well to the BS collapse called yeah, open it up using She Loves You, close it using She Liebt dich, or vice versa. We can do the same thing with modal windows. I'm going to create a modal window with all you need is love. The ID is, it's easy. "20 seconds, no more, no less." And then I create a button to open up that modal window and attach the ID of that modal window to the button. It works well with links as well, buttons or links. Hit love, and up comes your window, and it's a standard modal window. And the neat thing is it's all happening on the HTML side, on the UI side of Shiny, you don't have to rely on the server side. So this next example is with a tooltip. You have to use this special function use BS tooltip somewhere on your page. Then you create your button. I don't know why you say goodbye, and you can probably guess what the tooltip's going to say. You embed this tooltip. I say hello. Give it you can also put some placement options on it. You pipe that button into this BS embed tooltip, which will embed this tooltip into it, and then whenever you hover over your button, your tooltip will appear. So there's a few things that you can put together here. This is a Shiny input, and what I want to do is to be able to put a little help button right up in that corner there. And so what I do is I'll first use the use BS popover function that will enable the popovers to work on my page. And then what I will do is a few things. The first thing I'll do is I will create a link using a Shiny icon. There's a function, Shiny icon link, that will do that. I will embed my popover that appears here, and then I'm going to take that whole thing and embed it into the select input, so my help button appears up here. And these are all functions that are in the BS Plus package. So some parting thoughts here. I try as much as possible to conform to what Twitter Bootstrap has done for us already. There's some links there to it. There's a helper function, BS set data, that makes it easier to customize things further. It's on CRAN. There's a package down site. Thank you very much.
So I'll use the time. My name is Paulo Bargo. I'm from Jensen, so I'll just save all this 20 seconds nonsense. All right. I'm going to be talking about tags, which is a HTML widget for Excel data importation. And Paulo Bargo, that's it. All right. I'm talking about handling some Excel data, some benefits of tags, details about it, applications, and some future work. Handling Excel data is really the motivation why we get this. A lot of our scientists get data in Excel format. It's still a big standard. But the scientists get the data, the raw data, they do something with it, and then usually create some summarization or whatever. So they manipulate that table. You want to have a nice CSV table to import, but you don't get that. Usually you get something like this, and these are not hairy. These are somewhat simple. So you may have, a lot of tables on it, or you may have, the mean, the standard deviation, and you really don't care about this, but there's a problem. What do you do with this? So you resort on to either create a CSV table, so you're going to have to save your data somewhere else by creating some additional data. Or you may have to import the data directly from that table, but then you have to know exactly where the data is, and it may be difficult to get handle of metadata. So you may have a single data or multiple data, but metadata is really sort of lost unless you know. So you can use typical packages to read the data, like read XLS and so forth. So what we have here is a GUI to import the data. It gets information about the data, about the file automatically. You can add metadata to the file, and then you can export that into a JSON that you can either read later and use the data later, or you can use the data in that Shiny session as you're using it. So it's based on Shiny. It's using a JavaScript in the backend. And here's just an example of a Shiny app. So very simple. You browse to get your file. So you find your Excel file, which in this case is a very simple one. You have here on the top a table. You have a reference, which is the column around on the side. And you may did some manipulation, and you have like the percentage value based on that reference or something. So that's very simple. So what you do is you mark the data that you want, you right-click, and you tag the data. It opens a window where now you can input information about the data. So you can have a data name, so that becomes your data table name. If there is a header, you can click it. If there is some information on the columns, you can click it. And then you can also add whatever metadata that you want onto this. So now you can say it's related to, this is data without outliers, or this is data about product A, B, C. And all this information is gathered. So you can do the same with your table. You do that for the reference. You can do that with the other table if you want to. And then you can go back and edit and do whatever you want, or you can delete. And once you have that, you export it as a JSON file. And all this information is there without the payload. So one of the things that we wanted to do with this a JSON file is not to carry the data with the JSON file, so it's not too big. So that's how it is. This is an R object, so this is an R object. So you can either use that information directly into your Shiny section if you want to, or you can export the JSON file, and then you can open another R script that is going to find that data wherever it resides and gather the information that you care about without having to duplicate the data. So again, the applications that you have for this is really to easily import data from Excel spreadsheets, saving specific data from the tables, and not having to duplicate data, which is usually a problem. It takes a lot of time for the scientists to vet it, whatever you duplicated as a data. And that's what you have. Table that you can, a package where you can add metadata, you can create this JSON file. I'll put it in GitHub very soon. There was no time to do it before the conference, and then hopefully CRAN package. Thanks.
Thank you so much. Well done.
So can everyone hear me? Good. So my name is Tina Gunderson, and I work in the Department of Health Sciences Research at Mayo Clinic. And I'm here to talk about object-oriented markdown in R to facilitate collaboration. Deep breath, right? So what's the problem? You have an analysis that you want to do, and you want to easily be able to print or share your results, but you also want to minimize the effort that that's going to take to get to something that you can share. Also, ideally speaking, you'd like your results to be reproducible. You want to be able to collaborate with your coworkers to make use of your team, and you want to minimize redundancy, whether that's in terms of copying and pasting code that you have to add, or in rerunning programs, especially for computational analyses. I think that's the old version of the slides. So a lot of people at my institute use SAS, and so we're primarily sort of bringing SAS users over. And SAS is great in the sense of quick and dirty output, in that to run it is to print it, and it's going to give you everything it thinks that you want. Even for a simple t-test, you get 2 to 3 pages of results. So R is obviously different, not just in terms of its verbosity, but also that you have specific print methods that you're calling separately from the analysis. And those may sometimes be based on your output type, for example, if you're doing to PDF. So as a quick example, we're going to use our t-test, and obviously getting the components out isn't a problem. It's the translation from these functions to some sort of shareable output. And we want to minimize the difficulty that our users are going through to get these results. So this, unfortunately, is the old version of the slides, so I'm going to go with my speech rather than the slides, and I apologize for it not following along. So we also want to improve on what we can get out of SAS. So Markdown is one of those tools that we can use to easily incorporate things like interpretation of the results, as well as plots, without having to do something like proc template. So in terms of using, for example, full Markdown, putting everything in that document, it's okay for shorter analyses, but I found for longer programs that was starting to get unwieldy, it would be difficult to read. It was also harder to incorporate those collaborative results. When using something like source, it was great for sort of quick and dirty output, but if you didn't want to include everything, you would have to use explicit print statements, or you were starting to do things like rerun computationally expensive analyses. So what we were calling object-oriented markdown is divorcing that sort of doing from printing and doing what they're already sort of doing in R, which is saving your output as objects, and then at the end sort of selecting the relevant print methods that you're going to be using. So this has the advantage of reproducibility, so we want to programmatically go from a dirty data set to a clean data set. We want to be able to split up our analyses to make use of our team. We want to have these objects be loaded, so if they're doing iteratively, working on these programs, we just have the output objects that we're drawing from for our template. And we want to make this clear and easy to follow in the final document. So going back to our example with our t-test, we are just saving out those outputs in a simple list object. And then we're going to just use the markdown document to print those. So everything now is just formatting. And you can customize this based on your output type, for example, using Xtable and PDF very easily, or incorporating that sort of inline R code to do something like interpret the results. So in brief summary, we're just decoupling the analysis from the printing and using those steps to still get something that's reproducible, that integrates your team results, and that's easy to customize for new users to R. Thank you.
Well done, you did well.
All right, so my name's Sean Lopp. I work at our studio. I want to talk today about package management, which basically boils down to keeping track of what versions of a package you're using at any given time. And at our studio, we use a package called PackRat to help manage that dependency problem. So that's what we're going to talk about today. When I tell people that we use PackRat in production every day at our studio, most people don't believe me. And that's because PackRat can be a difficult tool to work with. So today we're going to look at two different strategies for using PackRat and talk about how you might choose a strategy that's appropriate for the workflow while still getting all those benefits. So the first strategy, which is the default in PackRat, is pretty aggressive. Basically what this comes down to is you start with an empty library, you create a library for your project, and as you use packages, you install everything, including the source, alongside of your code. And this is great because it means at the end you have a bundle that includes everything, but it's difficult to do. So an alternative approach is this passive approach to PackRat, where you start with a system library, and instead of snapshotting all of the package sources, you just keep track of the PackRat lock file, which includes the metadata and information that you need to later come back and restore that information. So let's look at this lock file. It contains a lot of rich data, including the version of R that you're using, the repositories and what those repositories resolve to, as well as obviously all your packages and the versions of those packages. And for packages from GitHub, it even includes things like the specific commit that you referenced when you installed the package. So to summarize, in these two approaches, you can either keep everything as you go, and then at the end, it's really easy to restore things, or you can just keep a lightweight file, and at the end, you have to do some more work to restore your environment. Maybe you have to go find those packages if PackRat Restore isn't automatic. What I'd argue is that the aggressive approach is painful, the passive approach is sometimes easier. Either way, you should use a global cache, so it's important if you have multiple projects to not be carrying around sources all the time. So in PackRat, there's a little known feature that includes this use cache option. And with that enabled, PackRat works the same way as virtual environment. There are also some alternatives I'd like to quickly touch on. So Checkpoint is a great package from Microsoft. Package Snap is a package from Gabor that achieves a similar end. If you buy into that passive approach, you might just use session info to capture a static file that you version. And then that file, you could get everything from it that you need manually. So if this is interesting to you, if you care about package management, let's go ahead and chat, or you can shoot me an email. Thanks so much.
Thanks, Sean. Can we also just have one last clap for all of our 10 speakers here today? Fantastic. I know that we're supposed to be getting on the bus and things, but are there any questions for any of our speakers here today? Or otherwise, I'm sure anyone that wants to answer a question? No, otherwise you can come up and I'm sure that they'll stick around for 5 minutes or so to answer your questions if you want. Cool. Thank you, everybody. Have a great night.